Density Experimental Design by Joaquín Narváez, Jerónimo López, and Tomás Mota. The experimental design we chose will be based on a modern commercial passenger jet. Specifically, we are taking the Boeing 787-9 Dreamliner as our lab red. It's a very complete model because it features cones, cylinders, rectangular prisms, and many other three-dimensional polygons. It will be a challenge to find the way of calculating the density for irregular 3D objects such as the one chosen. To find the density of the aircraft, it is necessary to have data about mass and volume of the aircraft. While we have the mass data available on internet and flight simulators, we need to find the volume. There are three different methods we can use to find out the volume. They have different complexity and different accuracy. We have the third method and the one that will be applied for this experiment. That will be the 3D polygon approximation. That would be an estimate outline of the real object using as similar geometric shapes in a 3D model. Then we find the volume of these shapes and add it up to estimate the real volume. Now here we have our 3D model with a 3D polygon approximation in SketchUp program, where you can see how we replace the aircraft's curves with cones, cylinders, and prisms to find easily the volume of each of these figures, and then to add them up and find an approximate volume. For the model we use real-life blueprints that show the real measures in meters to scale up the model properly and be able to measure the shapes and find the accurate volume, which was in this case 1343.95 meter cubed. Now that we have the volume, we are only missing mass, which is a very important variable since it is an independent variable considering fuel on board. This is measured in kilograms. Passengers on board will also have influence on the mass, as well as the passenger's corporal weight. So in this experiment we're having 7 different measures with different loading configurations that will give us 7 different densities. In the aeronautical industry, airlines tend to select the most efficient aircraft, and this, by calculating the volume, the mass, and the density, is a very good way to show how this finding volume, density, and mass is applied to real-life contexts that can lead into interesting results by different estimation methods.